Hello students, welcome back to physics class. Today I will teach you the topic of nuclear physics and the subtopic for this lesson is nuclear energy. As usual, before we start the class, I am going to inform you the learning standard for today's lesson. By the end of today's lesson, you should be able to describe relationship between energy released during nuclear reaction and mass defect as expressed by this formula E equals to mc squared, and you should be able to solve problems involving nuclear energy due to radioactive decay and nuclear reaction. As the first part of the learning standard, I will explain to you the relationship between energy released during nuclear reaction and mass defect. Before that, I will introduce the term atomic mass unit or AMU. Atomic mass unit is actually the unit of mass but not in the standard unit kilogram. It is actually a measurement of mass of an atom. Atomic mass unit is used as mass of an atom which is too small and too difficult to measure using the standard unit kilogram. A relative comparison between the mass of an atom with the mass of one carbon-12 atom is used. Isotope carbon-12 is used as a reference because carbon can be found in many compounds found on Earth. Okay, let's discuss the atomic mass unit AMU using the mass of one carbon-12 atom and Avogadro number. For the mass of one carbon atom is equal to 12 AMU. So this is the standard value. From this information, we can find 1 AMU is equal to 1/12 mass of one carbon atom. So now we want to find 1 AMU is what is the value for 1 AMU. And then, since 1 mole of carbon atoms is equal to 12 grams and 1 mole of atom is equal to Avogadro number, so between these two information, we can denote that this one as the first equation and then here is the second equation. So, we can eliminate 1 mole of carbon atom by equation 1 is equal to equation 2. So from there we can say that Avogadro number is equal to 12 grams. So as for this much of atom is equal to 12 grams, just now we want to find mass for one carbon atom. So one carbon atom is equal to 12 grams divided by the Avogadro constant or Avogadro number, which is 6.022 times 10 to the power of 23. So for one carbon atom, the mass is 1.99 times 10 to the power of negative 26 kilogram. Okay. We go back to this part and 1 AMU is equal to 1/12 times 1.99 times 10 to the power of negative 26 kilogram. So 1 AMU is equal to 1.66 times 10 to the power of negative 27 kilogram. So this is the relation between 1 AMU and kilogram. Let's move on to the relationship between energy released during nuclear reaction and mass defect. Both nuclear fission and nuclear fusion release a large amount of energy. The loss of this energy is from the loss of mass in nuclear reaction. This loss of mass is known as mass defect. The total of mass of the decay product is always less than the total mass of the radioactive nucleus. With that, mass defect is equal to the sum of masses before reaction minus the sum of masses after reaction. To help you understand more on mass defect, let's look at this example. So this is an example of nuclear fission. uranium-235 is bombarded by a single neutron, which results to unstable nucleus uranium-236. This uranium-236 splits into two or more lighter nuclei, which are krypton-92 nucleus, barium-141 nucleus, and also 3 neutrons are produced. During this fission, energy is also released. This is the mass of neutron and uranium-235 before fission. Then sum up the mass before fission, which is equal to 236.05259 AMU. And here is the mass after fission for krypton-92, barium-141, and also mass for 3 neutrons. Sum up the mass after fission, which is equal to 235.86653 AMU. So mass defect is the total mass after fission minus with the total mass before fission. So the mass defect is equal to 0.18606 AMU. From our discussion, we can say that both nuclear fission and fusion release a large amount of energy. The loss of this energy is from the loss of mass in nuclear reactions. A loss of mass in a nuclear reaction means that the mass had changed to energy. And Albert Einstein said that mass and energy can be exchanged one for the other. So the relationship between energy released during nuclear reaction and mass defect can be written as this formula. E equals to mc squared, where E is equal to total energy release, mass is the mass defect, C is the speed of light in vacuum, and 1 AMU is equal to 1.66 times 10 to the power of negative 27 kilogram. Let's move on to the second learning standard, which is solving problems involving nuclear energy due to radioactive decay and nuclear reaction. The question says, the equation below shows radium-226 decaying into radon-222 by emitting alpha particle. So this is the equation. Given that the mass of radium-226.54 AMU and radon-222.018 AMU, and for helium is 4.003 AMU. Calculate the nuclear energy release. And then this is the information needed to convert AMU to kilogram, and then the speed of light in vacuum. Okay, how to solve this problem? In solving the problems, first of all, you need to identify the problem. So the problem here is calculate the nuclear energy release. And then after that, you need to identify the information given. So you list out all the masses given. And then step number 3, identify the formula that can be used. So what is the formula that can be used to calculate the nuclear energy release? Yes, it is E equals to mc squared. So we know that m is equal to mass defect. Mass defect is the total mass before reaction minus with total mass after reaction. So mass of radium minus with mass of radon, and then minus with mass of alpha particle or helium. Then you get the mass defect is 0.519 AMU, and then convert into kilogram by using this formula. Okay, and then you get that mass defect is equal to 8.6154 times 10 to the power of negative 28 kilogram. And then you can solve the problem. Put in the values into the formula, and then The energy release, nuclear energy release is 7.75 times 10 to the power of negative 11 joule. Okay, second question. The sun is the source of energy to the earth. This energy is produced by the nuclear fusion in the core of the sun as shown in the following equation. So this is the equation of nuclear fusion in the core of the sun. And then the question asks, calculate the nuclear energy release in joules. And here are the information needed to help you in answering the question. Okay, this question is actually similar to the question before, question number 1. So I want you to try first and answer this question before we discuss the answer. Okay, same as before, the mass defect is equal to the total mass before nuclear reaction minus with total mass of after reaction. So this is the total mass before nuclear reaction and then minus with total mass after the nuclear reaction. And then you will get the answer in AMU and convert it into kilogram. So mass defect is 2.988 times 10 to the power of negative 29 kilogram. And then decide the formula that you want to use or the equation you want to use to get the answer, which is E equals to mc squared, and substitute all the information needed and you get that E is equal to 2.69 times 10 to the power of negative 12 joule. So this is the answer. For your extra exercise, you have to scan this QR code and you will be directed to the Google documents where I have already put all the questions there, and you need to submit the answer before our next class. Before I end our lesson, let's look at the summary of what we had learned today. So there are 2 learning standards that you learned today, which is the first one is describe relationship between energy released during nuclear reaction and mass defect, which can be expressed as E equals to mc squared. So from this learning standard, you learn how to convert atomic mass unit to kilogram. And then you also learn that mass defect is equal to the sum of the masses before reaction minus the sum of masses after reaction. And mass and energy are interchangeable and expressed as E equals to mc squared. For the second learning standard, which is solve problems involving nuclear energy due to radioactive decay and nuclear reaction, in solving the problems, first of all, you need to identify the problem, whether the problems wants you to find the energy release. And then identify the information given, where you need to list out all the information such as masses, and then identify the formula that can be used. The formula that can be used might be E equals to mc squared. And last one, you can solve the problems numerically. That's all for today's lesson. I hope with today's lesson, you are able to describe relationship between energy release during nuclear reaction and mass defect, which can be expressed as E equals to mc squared. And you are also already able to solve problems involving nuclear energy due to radioactive decay and nuclear reaction. Okay, students, thank you.